Good afternoon, everyone. For today's class, we are going to do a quick recap on what it was that we covered last time, which was solving linear inequalities, solving compound linear inequalities. We're going to continue with this idea just to see a few more examples before we move right into graphing linear inequalities. I would urge you all to, and I'm trying to find mine, give me 1 second. Where is it? There it is. I would urge you all to grab some sort of colored pencil or marker or highlighter or something so that way you can shade in your graphs using a different color. So we're actually going to get to color today, which is very exciting. I'm very happy about it. Okay, so let's continue with where we left off. We'll do a recap and then let's go through the rest of the notes. Once we're finished with the notes, we're done with Unit 7 for today. Let's check it out. So for last class, we left off with our compound inequality. We had -10 was less than 12b minus 3 all over 2 was less than or equal to 8. So the first thing we wanted to do here is we actually wanted to multiply every term by the LCD. The point of multiplying every term by the LCD was so that we can eliminate any fractions that we had. So notice the LCD here is 2, so we multiplied every term by 2. That gave us a -20 is less than, our 2's canceled. We were left with 12b minus 3 is less than or equal to, and then 2 times 8 is 16. Now recall that our goal for all of these problems is to isolate the variable. We are trying to solve for b. So if we have 12b minus 3 and we're solving two inequalities at once, thank you, Anthony, we are actually going to move the -3 by using the opposite operation to both sides. So we're going to add 3 to both sides because, like I said, we're solving two inequalities at the same time. Those go away. So now we have -20 plus 3, which is -17, is less than 12b, is less than or equal to 16 plus 3 is 19. Again, our focus is to isolate b. So in order to do so, we must divide every single term by a positive 12. It's a positive 12b, so we divide by a positive 12. We learned that the only time we would flip the direction of the inequality symbols is if we divide by a negative number. Luckily, we're dividing by a positive 12. So everything gets divided by 12. And we simplify. So -17 over 12 stays -17 over 12. Bring the less than sign down. Notice the 12s end up canceling, so it leaves you with b. Bring down the less than or equal to, and then of course bring down 19/12 because that doesn't reduce. Here is our answer. We always need to have our variable here, right? We are not just going to get rid of it. So -17 over 12 is less than b is less than or equal to 19/12. The next thing we did is we drew this on a number line, where our critical values are our two results here. We notice because of my less than symbol that we're going to have an open circle over the -17/12. We see here less than or equal to, so equal to means closed circle, so I close it right above the 19/12. The next thing we're going to do is write this interval in interval notation. So the image here, this graphic, is going to help us with interval notation. Notice because this is the only thing that's shaded in, we have our left endpoint and our right endpoint. So the left endpoint is -17 over 12. The right endpoint is 19 over 12. Open circle, open, right? We're approaching the number here, the -17/12, so we're going to use a parentheses. Close circle, close bracket. Think of it as rigid, rigid. Close, close the door. Hopefully you get that sense as you do these. Lastly, we want to write our answer in set builder notation, so we write out our set of braces, variable, bar, pick up the answer, write it inside, bam, you're done, moving on. Let's take a look at number 5. For number 5, we have -7 is less than 4y minus 7 is less than 14. Again, we have a compound inequality here. So we want to solve two inequalities at the same time. In order to do that, our goal is to isolate our variable. So we have 4y minus 7, which means we want to bring 7 to both sides. So let's add 7 to both sides, just like so. I want you to notice, hi James, I want you to notice that negative 7 plus 7 is 0, and that's okay to bring the 0 down. If you guys left that blank, then I would wonder, what would you put there, right? I mean, 0 is a valid number. Can we have $0 in our bank account? Yes, of course we can. It would be terrible, but we can. So 0 is a valid number. So negative 7 plus 7 leaves you with a 0. No big deal. We have less than, bring down the 4y. Notice your 7s, negative 7 and positive 7, they're opposites, so they cancel. Bring down your less than, and then 14 plus 7 is 21. Again, focus on the goal. The goal is to isolate the variable. We have 4 times y, so it makes sense to divide by 4. Because I am dividing by a positive 4, I do not need to flip the direction of the inequality symbols. So let's simplify. 0 divided by 4, 0. Bring your less than. 4y divided by 4, y. Bring your less than. 21 over 4 does not reduce, so you leave it as is. Next, we're going to draw our number line. We have 2 critical values, a 0 and a 21 over 4. Notice that my symbols are less than, meaning they're both going to be open circles. If we had less than or equal to, the equal to part indicates it would be a closed circle because we're including the value. But because these are both less than, we are not including the value. So open circle, open circle. Next, consider where y is. Y is greater than 0, but y is smaller than 21/4. So if y is greater than 0 and smaller than 21/4, we are here on the number line. So y represents all the values between 0 and 21/4. So because we have this wonderful number line displayed, we can simply translate this into interval notation. Notice here's my interval. I have a left point and a right point. So we've got 0, 21 over 4. Because I have an open circle here, I'm going to use a parentheses. So essentially I'm approaching 0, but I'm not including it. Same thing with the 21/4. I'm approaching the 21/4, but I'm not including it. So here's my interval notation. The next thing we want to do is we want to write our answer in set builder notation. I always like rewriting the actual name because it reminds me that I'm working with a set of braces. So we're first going to draw our set of braces. Hi, Nicole. We draw our set of braces. Our variable happens to be y, so I'll bring that down. I'll bring the vertical line. Remember from last class that this means the set of all elements y such that, and now all you have to do is take this entire thing, pick it up, and put it right inside. So you have 0 is less than y is less than 21/4. And you are done with this problem. I hope you're looking at this and you're thinking, wow, that's actually not bad. Let's do it again for number 6. For number 6, you have 12 is less than or equal to 3m plus 2 all over 6 less than 15. So with this same case, because we have a fraction here, we are going to want to multiply by the LCD to eliminate our fraction. So I'm going to multiply every term in this case by the LCD, which is 6. And honestly, think about it. 6 is the only value we have in a denominator outside of 1. So 6 is our LCD. 6 times 12, that's going to give us 72, is less than or equal to. Now remember, the point of multiplying by the LCD is to eliminate your fraction. So I'm going to cross out the 6's here. 6 divided by 6 is 1, so it goes away. If 6 divided by 6 is 1, 1 times 3m plus 2 is 3m plus 2. Is less than, and then 6 times 15, well, that's going to give us 90. Awesome. Now that we've eliminated that fraction, we can go ahead and solve this linear inequality by moving terms around. So for instance, because I want to get 3m initially by itself, I got to get rid of that 2. So I'm going to subtract 2. We're going to bring that to both sides because I am solving 2 inequalities at the same time. 72 minus 2 is simply 70. Bring down the less than or equal to. Bring down the 3m. Notice these 2's are opposites. They eliminate each other. Bring down the less than, and 90 minus 2 is 88. Next, I'm going to isolate the m by getting rid of 3, and we would do that by dividing. So I'm going to divide each term by 3. Now notice that we actually can't reduce this further. One way to check if you could reduce this further is by adding the digits. So for instance, 7 plus 0 is 7. 7 is not a multiple of 3, so you know 3 cannot go into 70. So we leave it 70 over 3, less than or equal to. 3 divided by 3 is 1, so that goes away. We're left with m less than, and then 88 over 3, but let's double check. 8 plus 8 is 16. 16 is not a multiple of 3, so we cannot simplify further. And there's our solution. The next step would be to draw this on a number line. I'm going to have 70 over 3 to the left of 88 over 3 because remember, we're talking about a number line. 70 thirds is smaller than 88 thirds. Let's look at our inequality symbols here. If 70 over 3 is less than or equal to m, then we know because of the equal to part that we're including the 70 over 3. In our second side, m is less than 88 thirds, which means that we are going to approach 88 thirds, but we're not going to include it. So it's an open circle. Because m is larger than 70 thirds, but smaller than 88 thirds, we would shade in between. Now you're probably thinking, will that always happen? No, it will not always happen. So you need to verify that it's actually set up in this appropriate form. I will tell you that the problems you see in 096 will be straightforward like this. But for future math classes, dissect your inequalities carefully. Dissect them carefully. All right, now that we have our visual, we're going to go ahead and write this in interval notation. Interval notation is a left bound, right bound, left end, right end. So the left end is 70 over 3. Because it's closed on 70 over 3, we're going to close it here by using a bracket. Close the door. Comma. And our right end is 88 thirds. Because it's open here, we're going to use a parentheses. So open, we're approaching it. And that's interval notation. I hope you don't mind me abbreviating. Lastly, we want to write our answer in set builder notation. So for set builder notation, we're going to draw our set of braces. Our variable in question is m, put the vertical line, and now pick it up and write it right inside. 70 over 3 is less than or equal to m is less than 88 over 3. Wonderful. What I want you all to do is take a moment to answer number 7. So I'm going to give you 2 minutes to run through number 7, draw it on a number line, write your answer in interval notation and set builder notation. In case this is a little hard to read, this says negative 52 plus 22 divided by 11 is less than or equal to negative 2 times 4n minus 5 plus 10. 2 minutes starting now. Type in your answers into the live chat so I can see what you're getting. Go for it. All right, let's see how you all did. So we had negative 52 plus. I am hopeful that you saw 22 over 11 and said 22 divided by 11 is 2. And you wrote plus 2. Always simplify whenever you can. So then we have less than or equal to. In front of the set of parentheses, we have a negative 2. So we're going to distribute to both terms. Negative 2 times 4n is a negative 8n. Negative 2 times a negative 5 is positive 10. and of course bring down the plus 10 here. Now that we've distributed everything, we're going to clean up and see what happens. Thank you, Alyssa. Let's check out that answer. So negative 52 plus 2 is negative 50. Next, we have negative 8n. 10 plus 10 is 20. So far, so good. Hopefully my work matches yours. Next, we are going to bring 20 to the 50 so that we can get our n term by itself. We always want to isolate our term with a variable. So I'm going to subtract the 20. That gives me negative 70 is less than or equal to negative 8n. Okay, let's take a look. Thank you, Christina. Let's check it out. At this point, we want n by itself. So we're going to divide both terms by negative 8. Did you hear what I said? Divide by negative 8. So because I'm dividing by a negative 8, I must flip the direction of the inequality symbol. So right away, we know that we're going from less than or equal to greater than or equal to. Negative 8n divided by negative 8 is just n. Keep n on the right. Do not accidentally bring this over here and flip the sign and then bring this expression on this side. No, no, no. Leave everything exactly where it is. Okay? We'll dissect it later. Next, we have negative 70 over negative 8. I want to point out to you something. Negative 70 divided by negative 8. First off, the negatives are going to cancel. 70 over 8, when you see this fraction, your gut instinct is to reduce, right? So let's reduce this. If we divide both by 2, that gives me 35 over 4. Very nice, Christina. 35 over 4. Now, I'm going to read this to you. 35 over 4 is greater than or equal to n. It's very important to note what this says. 35 over 4 is greater than or equal to n. So excellent job. So essentially what this means is that n is less than or equal to 35/4. That's going to be important as we graph this on a number line. 35/4 will be the center of my line. Notice here that because we have the equal to, it's going to be a solid circle. Since n is less than or equal to 35/4, we want to shade to the left. Less than, left. Greater than, right. Less than, left. Wonderful. Now we're going to write this in interval notation. Interval notation states you're going to look at the left end and then the right end. The left end is this arrow, and as we continue to the left, we're going towards a negative infinity. Left end is a negative infinity. We're going to approach negative infinity. You can never close it. You cannot say infinity, you end here. No, it doesn't work that way. Okay? So you're approaching negative infinity. The right end point is 35/4. Because we're closing this circle here, we're going to close the interval here. We're essentially closing, we're including our 35/4 in our result. That's interval notation. Lastly, we want set builder notation. So we need our braces. My variable is n, put the vertical bar, and then if you want, you could just write in here 35/4 is greater than or equal to n, or if you wanted to, you could write n is less than or equal to 35/4 because these say exactly the same thing, right? They say exactly the same thing, which is why your graph reflects that particular inequality. Very nice. That concludes the section on solving linear inequalities. What we're about to do is get into graphing linear inequalities. So what I would urge you to consider is think back to Unit 4 when we wrote our equation in slope-intercept form. Slope-intercept form, y equals mx plus b, where our m is our slope and our b is our y-intercept, right? Once we had that information, we were able to graph it. We are going to do the same thing here, treating that inequality symbol like an equals, right? except that because we want to graph a linear inequality, we have a couple other things to consider. I'm going to try to break it down as simple as possible so that it's no brainer, it's a no big deal, okay? I'm hopeful that after we go through this section together, you will actually feel pretty confident about doing these on your own. So let's take a look at graphing linear inequalities. Okay, as a reminder, slope-intercept form, y equals mx plus b, where m is our slope and our b is our y-intercept, right? And I've even written it here, but I'd like to kind of illustrate that in the equation itself. So when we graph linear inequalities, we have to consider two bits of information. The first bit is whether or not our line is solid or dotted. Here is a very easy way to think about this. When we were graphing on our number line, anytime we had less than or greater than, that would be an open circle, correct? Because we're not including the value. So if for less than or greater than, it would be open circle, I want you to think that the line should then be open line. And what's another way to say open line? Well, that's dotted. If our inequality symbols are less than or equal to or greater than or equal to, you recall that on the number line it would be a closed circle, correct? We're including the values. So if it's a closed circle, meaning if it's equal to, we will then have a solid line. And I have that illustrated here. Notice less than or equal to, greater than or equal to, solid line, solid line, solid line, solid. For less than or greater than, that's open line, or in other words, dotted. That's the first piece. So we have to consider, is our line solid or dotted? The second thing is we have to consider, where are we going to shade? Am I going to shade above or am I going to shade below? Here's how I want you to think about it. For this statement right here, this linear inequality, this reads y is greater than, and it honestly doesn't even matter what else it says there. Notice here it says y is greater than. Because y is greater than, you're going to shade above. If your inequality symbol is greater than or equal to, same thing, you shade above. If conversely you have y is less than or equal to, or y is less than, we'll shade below. So I'm going to write here y is less than. That implies we're going to shade below. At some point during your notes, I will show you how to test this to make sure that you shaded the correct region. But let's keep going. Let's graph each linear inequality, and we're going to use a different colored utensil to shade in the appropriate region. I'm going to use my pink Sharpie, or in other words, my highlighter. Okay, first we have y is less than 2/5 x minus 1. Let's begin by writing out what the slope is. The slope in this case is 2/5. As a reminder, slope is rise over run. So this means we're going to rise 2 and run 5. Again, you always want to run to the right. Next, we want to identify our y-intercept. Our y-intercept in this case is 0, -1. The next thing I want to consider is whether or not the line is solid or dotted. Notice we have y is less than, so because there is no equal to piece here, it's just simply y is less than, this is going to be open circle, open line, meaning dotted. And lastly, let's figure out where we're going to shade. Again, let's read it. Y is less than the line. So y is less than, so we shade below. all we have to do now, everyone, is combine these things together. So we always start by plotting our point. Slope is not a point. Our y-intercept is a point. You see it? 0, -1? Let's start there. 0, -1. Now I'm going to apply the slope. Think of that as a direction, right? Like a directive. You're going to rise 2 steps, 1, 2, and run 5 steps. 1, 2, 3, 4, 5. And just for the sake of doing it, we're going to rise 2 and run 5 again. So 1, 2, run 1, 2, 3, 4, 5. I'm going to grab my straight edge, and I'm going to connect these points with a dotted line. Not a solid line, a dotted one. So I've got good. Make that line nice and long. And then all we have to do is shade. So we determined that because of the way that we had, because of the way the inequality is written, y is less than 2/5 x minus 1, we will shade below. You see all of these y's? All of these y's are below this line, so y is less than. Implies we shade that region. Not bad, right? Let's do it again. Y is greater than or equal to -1/4 x plus 6. Let's go through the same flow. First thing, what is my slope? I'm hopeful that you all said -1/4. If you said the slope was -1/4, you mean that we are going to fall 1 because it's negative, and we will run 4. But we always run to the right. Don't run backwards. Next, my y-intercept. Your y-intercept will always be expressed as an ordered pair. So hopefully you all said 0, 6. Beautiful. Next, we have to figure out what kind of a line this is. Is this a solid line or is it a dotted line? Well, take a look at the inequality. The inequality is greater than or equal to solid line, solid line. Very cool. And lastly, we need to figure out where to shade. I'm going to read it again. It's always helpful to read it out loud. Y is greater than or equal to the line. So if y is greater than implies we're going to shade above. All right, let's do it. Start with the point, 0, 6. 1, 2, 3, 4, 5, 6. Here's 0, 6. Now I'm going to apply the slope. Down 1/4. 1, 2, 3, 4. Let's do it again. Down 1/4. 1, 2, 3, 4. Good. Now that I have my points, we're going to connect with a straight line. Arrows on both ends. And now let's shade. So we've indicated that we have to shade above. Let's go ahead and do that. Now, before we look at number 3, I want to teach you about testing the region to make sure that you shaded the correct space here. In order to determine whether or not you shaded the correct region, what you'll want to do is pick a point somewhere in the region you selected. So I'm going to pick at random, let's do, I don't know, this point right here. This is going to be a test point. This particular test point is 2, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to test the point 2, 8. Let me show you what this looks like. So let's test 2, 8. We're, again, trying to verify that we shaded the correct region. If I take these coordinates and plug them into my equation and prove that it's a true statement, then I did, in fact, shade the correct region. So let's prove it. So I have y is greater than or equal to negative 1/4 x plus 6. Y in this case is going to be 8, greater than or equal to negative 1/4 times 2, because x is 2, plus 6. So let's do the math. 8 is greater than or equal to, now I want you to consider we can reduce here, 2 into itself once and into 4 twice. So if this becomes a 1 and this becomes a 2, that leaves me with negative 1/2 plus 6. Do you all agree that if I have a negative 1/2 and I add 6, that essentially this means 6 take away 1/2? And if 6 take away 1/2 results in 5.5, then we know for certain that 8 is in fact greater than or equal to 5.5. So because this is a true statement, we know we shaded the correct region. For the sake of proving to you that that wasn't a fluke, I'm going to pick a point at random from the region I did not shade. And just because I feel like it, I'm actually going to choose 0, 0. I like things to be pretty easy, right? Why not? We'll make this very easy on ourselves. We're going to test 0, 0. Same thing. Let's take our original equation. Y is greater than or equal to negative 1/4 x plus 6. And now I'm going to plug in 0 for y and 0 for x. So 0 is greater than or equal to negative 1/4 times 0 plus 6. Negative 1/4 times 0 is 0. And 0 plus 6 is 6. Is 0 greater than or equal to 6? No. So we know for a fact that we did shade the correct region. Awesome. Now think back to Unit 4. There were certain cases where the equation was not presented to you in slope-intercept form. It was presented in standard form or some sort of derivation of that, but it was not slope-intercept form. You were all responsible for rewriting the equation in slope-intercept form so that you could then graph using the slope and using the y-intercept. We're about to do the exact same thing, okay? Let's take a look. Number 3, we have 4x minus 2y is less than 4. Again, because the focus is isolating y, I'm going to subtract 4x. That leaves me with negative 2y is less than, now be careful, 4 and a negative 4x, they are not like terms. You cannot just combine them. It's not how it works. What we'll want to do, just like we did in Unit 4, is we want to write this in descending order. So we're going to start with the negative 4x and add 4, right? Negative 4x plus 4. You see it here? Next, I want to get y by itself. So I'm going to divide every term by a negative 2. Because I am dividing by a negative 2, I must flip the direction of the inequality symbol. That doesn't change. That will never go away. Negative 2y divided by negative 2, well, that's just y. Flip the direction of the inequality symbol. Negative 4x divided by negative 2 is a positive 2x. Positive 4 divided by negative 2 is a negative 2. And now, the rest is no big deal. Start with the slope, then the y-intercept. Then determine what kind of line. Then figure out where you're going to shade. All 4 steps, exactly the same. I am hopeful that you all identified the slope as 2, not 2x, just 2. But because 2 is a whole number, let's write that over 1 so that we can show that we are rising 2 and running 1. And remember, we always run to the right. My y-intercept is the b part of my slope-intercept form, so 0, negative 2. My line in this case is going to be dotted because there's no equal to. So it's an open circle, meaning open line, so dotted. Lastly, determining where we shade depends on what this says. This reads y is greater than the line. So because y is greater than the line, we will shade above. All right, let's graph it. Start with our ordered pair, 0, -2. Here we go. Rise 2 units, run 1. 1, 2, run 1. 1, 2, run 1. Let's do it again. Run 2, run 1. Rise 2, run 1. So now we are going to connect these dots with a dotted line. And there you have it. Arrows on either end. We've determined that we are going to shade above the line. So that's everything up here. And there's your solution. There's your graph. All of the coordinates in this shaded region belong in your solution. Every time we have greater than, y is greater than, we will always shade above. So Anthony, to your point, anytime we have y is greater than the line, you'll always shade above. If it's y is less than the line, that's when we shade below. Excellent. Try number 4 on your own. 4 is tricky. Don't overthink it. You know what the steps are. Get y alone, identify the slope, y-intercept, what type of line, and the region you're going to shade. Let's just do 60 seconds, see how you do, and I'll check in, starting now. Okay, let's take a look. Oh, we've got lots of answers coming in. Let's check it out. So we have 3x is greater than or equal to 6y. Okay, first things first, divide by a positive 6. Because I'm dividing by a positive 6, I don't need to flip the direction of the inequality symbol. What I will do is I'm going to say that -3/6 reduces to -1/2. So we have -1/2x is greater than or equal to y. Okay, I love it. Let's check this out. The slope in this case is, in fact, -1/2. Alyssa and Brittany, excellent. So we have -1/2 is our slope. So I'm going to say that this means fall 1, run 2. Because there is no b, think of this as +0 or +0. Our b is going to be 0, 0. That's our y-intercept. You can add 0 to this side and it will not change it. So it's kind of an indication. We can also plug in 0 for x and verify that y is also 0. Excellent. Our line in this case is definitely going to be solid. Okay, excellent. Anthony, you asked a really good question. We do not want to add the 3 to both sides because this is one whole term. So you can't add a 3x over here since the goal is to isolate y. You just want to think of y equals mx plus b, which means you only want to get y by itself. Y is almost alone. The only thing we had to do was get rid of that 6. So focus on y, divide by 6, and bam, just like that, we got y by itself. So to continue, we know our line is definitely solid. Greater than or equal to, the equal to implies solid. Now, let's talk about shading. If we read this from left to right, this reads -1/2 x is greater than or equal to y. So because -1/2 x is greater than or equal to y, let's read it the reverse. That means y is less than or equal to -1/2 x. So Christina, Alyssa, Brittany, beautiful. You are going to shade below. Very nice. Let's put all this together. Start at 0, 0. Down 1/2, down 1/2, down 1/2. We are going to draw a solid line here. And then we're going to shade below. Again, if that idea is weird for you, I want you to reread what our inequality shows. Negative 1/2 x is greater than or equal to y, which implies that y is less than or equal to negative 1/2 x. So because y is less than the line, you shade below. You are all doing awesome. We are actually almost done. We have another page to take a look at a couple more examples because obviously I want to show you a bunch of different types so that you're not surprised when you attempt these on your own. Number 5. Number 5 reads x minus 3 is less than 1. I'm hopeful that your gut instinct says you got to get x alone, right? If we get x alone, this time I do have to add the 3. Do you see the difference, Anthony? In this case, I want to isolate x, which means we've got to get rid of minus 3 by doing the opposite operation, adding 3. So that leaves me with x is less than 4. Recall from Unit 4 that we have horizontal and vertical lines. Remember what those equations were. Every time we had a vertical line, remember what that equation looked like. Every time we had a horizontal line, think back to what that equation looked like. We're about to see it again. So let me show you how this is applied here. We've got that x is less than 4. If you think about this as what we were used to in Unit 4 being x equals 4, well, if that's the case, in order to graph this, I need 2 ordered pairs, right? Where x is 4. So because x is 4, y could be anything I want it to be. So I'm going to make this 0 and I'm going to pick a 3 just because I feel like it. X has to be 4 in order to graph this vertical line. So 4, 0, 1, 2, 3, 4. There's 4, 0 and 4, 3. 1, 2, 3. Those are my 2 points. We know for a fact that my line is going to be dotted. X is less than 4, so this is going to be dotted. So let's go ahead and draw our dotted line. Arrows. And now let's think about what the shading implies. X is less than 4, so less than meaning shade below, right? But what the heck does shade below look like when you have a vertical line? Think about this logically. If x is less than 4, wouldn't that be something like 3, 2, 1, 0, -1, -2? You're contributing your answers, Brittany and Christina? Yes. So essentially what that means is we would shade to the left since all those values are less than 4. All those x values are less than 4. Perfect. That was wonderful. Do the same thing for number 6. This time I'm only going to give you 30 seconds. Number 6 reads, -3y plus 2 is less than 14. 30 seconds starting now. You've got this. Let's check it out. First things first, you'll want to subtract 2. -3y is less than 12. Next, we're going to divide by -3. Notice I said negative. So we divide by a -3, which means we flip the direction of the inequality symbol. 12 over -3 is -4. So we have y is greater than -4. I need 2 ordered pairs in order to graph a line, right? X, y. Y in this case is going to be -4, which means x could be anything you want it to be. So let's make that 0 and I don't know, I'm going to make it 2. So 0, -4, 1, 2, 3, -4, and 2, -4 is here. This implies we have a horizontal line. So as Brittany is stating, our line definitely has to be dotted. In terms of shading, we know that because it says y is greater than, Brittany says let's shade above, and she is totally correct. Very, very nice. Let's check this out. So we need to make this a dotted line. And we are then going to shade above. All of the y values in this region are greater than -4. Wonderful. I hope that was a piece of cake for you guys. I have a challenge for all of you, and that is to attempt to write the equations for these two linear inequalities, for these two graphs. So think about what we just did here. We took a linear inequality, we identified its slope, we identified its y-intercept, we determined whether it was solid or dotted, and then we also determined whether we were shading above or below. What I want you to do with these two is to work backwards from there. Work backwards, write down all of the key points, and then tell me what was the original linear inequality for this one, and what was the original linear inequality for this one. So I would like you all to try these and then shoot me an email. Let me know what your answers are for those. Before we end today's class, I want to really quickly show you that you have an overview. So I have typed up a summary of everything that we covered in our Unit 7. So essentially, if you did not have access to the video, you can read through these notes and get a sense of what it was that we covered. So just for the sake of showcasing this, for anyone who may not have access to the notes, you could always pause the video when you rewatch this. I simply want to show you what I have here. Notice we covered graphing on a number line, set builder notation, interval notation. We even covered compound inequalities. And then I gave a little bit of information in terms of word problems in case anyone who's watching is not taking my class, but has word problems dealing with inequalities. So here's a perfect example. And then I've also included an overview of graphing linear inequalities. On that note, we're done with Unit 7. Excellent job today. I am so glad that you joined me. I'm hopeful that this unit was fun for you. Anthony, you're crazy. I'm hopeful that this unit was fun for you, that you were just like, yeah, okay, this makes sense. I like it. And I'm really hopeful that the assignments in Lumen are a piece of cake, because Unit 7 is great, right? You see? You like it? I hope so. Maybe. All right, excellent. Anyways, be safe. Please stay at home. Take care of yourselves, though. Stay sane, stay happy. And I will see you all on Tuesday for another YouTube video. Okay? Bye, everyone.